Hi everyone and welcome back to your second lesson on special numbers. So for the first lesson we were looking at multiples, so we're working with our times tables. Today we're going to be working with our times tables again, but in a slightly different way. Today we're going to be talking about something called factors. Okay, so I'll explain what that is just in a wee minute. As always, can you please attempt these 3 starter questions for me? So for question 1, you have to convert to a 12-hour clock. So you have to change 7 15-hours and 5 40-hours to a 12-hour clock. For number 2, you have to do the sum 5.65 minus 1.3. I'd like you to write that out as a sum. Okay, you can try it in your head and you can do it as a sum. Okay. For question number 3, I would like you to round these numbers to the following, round them to 100 rather. So A, 13,551 and B, 369,449. Come back once you've tried them. Okay, welcome back. So for question number 1, if you change 17 15-hours to a 12-hour clock, you should have an answer of 5:15 p.m. Now, because this number here, this 17, because it's greater than 12, that tells you it's an afternoon, so you need to have p.m. in your answer. If you don't have p.m. in your answer's not correct, it's wrong. Okay. For part B, 05 40-hours, you should have 5:40 a.m. This number here, 05, is less than 12, so therefore it's in the morning, so we need a.m. in our answer. Okay. Right, question number 2, we need to set up a wee chimney sum. So we are doing 5.65, take away 1.3. So in this gap here, we should put a 0. Okay. 5 take away 0 leaves me with 5. 6 take away 3 is 3. Oh. Don't forget to put in your decimal point. And 5 take away 1 is 4. So your answer, guys, is 4.35. Okay. Right, round the following to the nearest 100, 13,551. 551, is it closer to 500 or 600? It's closer to 600, so your answer is 13,600. For part B, 369,449, so we're looking at the 449. Is that closer to 400 or 500? It's closer to 400, so your answer is 369,400. Okay. Right, today we're doing factors. So we want to find numbers. So we are learning that a factor divides into a number exactly, so there is no remainder. And then for the second part of the lesson, we are learning how to find the highest common factors. Okay, so how will we know if we're successful? We'll know if we're successful if we can identify factors using factor pairs. I'll show you what that is in just a second. And then if we can find the highest common factor for 2 numbers by comparing factors. HCF, guys, is just shorthand for highest common factor. Mathematicians are really lazy. They're always trying to find short ways to write things. So highest common factor, this here, we always just write as HCF. Okay. Right, so we want to find the factors of the number 9. So basically what we're trying to do is think of all the numbers that will divide into the number 9 that leave no remainder, so they divide into them exactly. Now when we do this, the easiest way to do it is always to start with 1. 1 times what makes 9? 1 times 9 makes 9, so there's our first 2 factors. 1 is a factor, 9 is a factor. Okay, then we go to the number 2. Can I do 2 times something? So is 9 in the 2 times table? Nope. Then we move on to 3. 3 times table. Can I do 3 times something to make the number 9? I can always do 3 times 3 to make the number 9. Okay. What you'll notice up here is that 1 and the number itself are always factors. So we were trying to find all the factors of the number 9. So 9 is always going to be an answer. The number 1 is also going to be an answer. Okay. So in total we've got 3 factors here. Our 3 factors are 1, 3 and 9. So our factors of the number 9 are 1, 3 and 9. Okay, that was our first example. For our second example, I would like us to find all the factors of the number 12. So again, starting at the number 1, 1 times 12 makes 12. Move on to the number 2. 2 times what makes 12? Think of your 2 times table. 2 times 6 makes 12. Moving on to our 3 times table. 3 times what can I make 12? 3 times 4 makes 12. If we moved on to our 4 times table, how many 4s would make the number 12? It would be 4 times 3, which is just the same as 3 times 4. So I stop at this point. I've found all my factors. So if I write them down in order, our factors of the number 12 would be 1, 2, 3, 4, 6 and 12. We're basically just following this down here. So 1, 2, 3, 4, 6 and 12. There is 6 factors of the number 12. 1, 2, 3, 4, 5, 6. Okay, so moving on to our third example, we want to find all the factors of 10. So again, starting at the 1 times table, 1 times 10 makes 10. Okay, so the number 1 and the number itself are always factors. Move on to your 2 times table. 2 times what makes 10? 2 times 5 makes 10. Moving on to your 3 times table. Is the number 10 in your 3 times table? Nope. Your 4 times table? Is 10 in the 4 times table? It's not. And then we would be on to our 5 times table, and we've already got the number 5, so we know we can stop at this point. So there's 4 factors of the number 10. 1, 2, 5 and 10. They all divide into the number 10 exactly, leaving no remainders. Guys, what you should notice as well is that your factors are always the same as the number or less, so you will never have an answer that is greater than the question, if you like. So if we're trying to find all the factors of the number 10, our answer should all be 10 or less. It cannot be a number bigger than it. Okay. Right, fourth example, I would like you to find all the factors of the number 15. So pause this video and try this one yourself, guys. So start at the 1 times table and then work your way up to see if you can find all the numbers that divide into the number 15 exactly. Okay, so for the number 15, if we start with the 1 times table, our first answer we should have is 1 times 15. So if we move on to our 2 times table, can I do 2 times something to make 15? I can't, no, 15 is an odd number, it won't be in the 2 times table. Your 3 times table, 3 times what makes 15? 3 times 5. Onto your 4 times table, can you do 4 times something to make 15? You can't, no. So we would move on to our 5 times table. We've already got the number 5, so that's us. We've got all our factors. Our 4 factors of the number 15 are 1, 3, 5 and 15. Okay. Right, say which of the following statements are true and which are false. So 7 is a factor of 28. So will 7 divide into 28 exactly and leave no remainders? Yes, it will. Okay, so it's true. 7 times 4 makes 28, so it is a factor. Right, B, is 5 a factor of 36? So will 5 divide into 36 exactly? No, it won't. 5 times 7 makes 35, but we don't get 36 at any point. Right, for C, is 8 a factor of 54? So think about your 8 times table. Can you do 8 times anything to make 54? No, you can't. 56 is in the 8 times table, but 54 is not. Okay. And the last one, is 12 a factor of 36? It is, yeah. 12 times 3 makes 36, so that statement is true. Okay. Right, guys, your turn. So from the worksheet from lesson 2, I would like you to attempt questions 1 to 5. I would like you to mark your answers. Once you've got them and you know that you have a solid foundation and an understanding of what factors are, come back to the video and we'll do the highest common factor. Okay.